Hello, 5th grade. Today we're on lesson 97. Lesson 97, the objective found on page 633 is use a ratio to describe the relationship between two numbers. I guess we'll dig a little bit deeper into that very soon. But the main word there is ratio. A ratio is a way of comparing two numbers by division. Okay, on page 633 at the bottom it says, if there are 12 boys and 18 girls in the class, okay, 12 boys and 18 girls in the class, then the ratio of boys to girls is 12 to 18. We'll write those ratios. I guess you can write it 12 to 18. You can write it 12 to 18, or they will commonly show these ratios as fractions. The ratio of boys to girls is 12 to 18. Okay, I'll keep reading. It says, we often write ratios as fractions. We write the terms of the ratio in order from top to bottom. So again, there were 12 boys, 12 is written on top. There were 18 girls, 18 is written on the bottom. The ratio is 12 to 18. Now the ratio, I guess I'm kind of skipping ahead. The ratio of 12 to 18 is a fraction, as you can of course see. And these fractions and these ratios can be reduced. Remember that we reduce fractions by finding greatest common factor and dividing both terms in the fraction by it. The factors of 12, I know, are 1 and 12, 2 and 6, 3 and 4. The factors of 18, 1 times 18 is 18, 2 times 9, 3 times 6, and 4 times, that's everything. Now I go back and I check which factors they have in common, and it looks like the greatest common factor is 6. I divide both terms by 6. 12 divided by 6 is 2. 18 divided by 6 is 3. And I find that the ratio of boys to girls is now 2 to 3. And again, it's just a reduced fraction. I'm going to talk a little bit about reducing fractions before I dig deeper into ratios, because it's something that I think we need to spend a little bit more time on, because it's not something that we're doing really spectacular at. So let's practice it a little bit more. We've discussed a few ways on how to reduce fractions. Okay, first we talked about finding greatest common factor, dividing both terms by that greatest common factor, and getting your answer. But this is a very tedious process. It does take some time, and it does kind of leave a lot of room for mistakes. So yes, if you feel comfortable doing this, if you find the correct greatest common factor, you will reduce the fraction. All right, but there are other ways to do it. Typically, if both numbers are even, you can of course divide both fractions by 2. Okay, now if you divide 12, can't do that. No Packer colors on my board. If you divide both fractions by 2 over 2, you will reduce that fraction, but it will not be reduced as far as it can go. Okay, 12 divided by 2 is 6. 18 divided by 2 is 9. Okay, now both terms are not even, so you cannot divide by 2 halves again. You have to find the greatest common factor of the numbers left over. It is often easier to do it like this. Find the greatest common factor of 6 and 9. Well, I know that 6 only has 4 factors, and I know that 9 only has 3. Whoop, sorry. 2 times 3 is 6. 1 and 6 also equals 6. So the greatest common factor of these two numbers is, of course, 3. Then you can divide both terms by the greatest common factor of 6 and 9, which is 3. 6 divided by 3 is 2. 9 divided by 3 is 3. You end up with the same answer either way. All right, it's just this one kind of has not an extra step, because the other way, finding the greatest common factor, took a little bit longer. But I think this is kind of an easier way to do it, and I guess it's whatever you feel comfortable with. if you'd like to recognize that both terms are divisible by 2, both terms are even, you can start by dividing both terms by 2 and getting smaller numbers to work with before you find greatest common factor. All right, let's look at the first example found on page 634. You will write this answer down for under the example 1 line. It says there were 12 girls and 16 boys in the class. So we have 12 girls, 16 boys. All right, so the ratio of girls to boys is 12 to 16. Oh, sorry. It said there were 12 girls, 16 boys. What is the ratio of boys to girls? Remembering that because they asked us what the ratio of boys to girls was, we put the first term in the top. So boys to 12 girls. So the ratio of boys to girls is 16 to 12. Now we need to reduce this fraction. And let's do it the way we just kind of discussed. Let's understand that both of these terms are even and divide both by 2. So 16 divided by 2 is 8. 12 divided by 2 is 6. I still see that both of these terms are even. So again, I can divide by 2 halves. Okay, I'll divide each term by 2. 8 divided by 2 is 4. 6 divided by 2 is 3. Okay, and this is a reduced fraction as far as ratios are concerned. But it of course is an improper fraction. But because we're dealing with ratios, improper fractions are okay. So the ratio of boys to girls is 4 to 3. And that's what you'll write down for example 1, your answer. Lesson practice. They do a few different things. First it says there were 20 prairie dogs. I'll just write PD. And there were 30 jackrabbits. It says for part A, which you will write down on example 2, write down this for example 2. It says, what is the ratio of jackrabbits to prairie dogs? Okay, understanding that they asked for jackrabbits first, prairie dogs second. So it's 30 to 20. Both of these terms end in 0, so these are usually pretty easy. You divide both by 10. 30 divided by 10 is 3. 20 divided by 10 is 2. For example 2, the answer that you will record is 3 to 2. The ratio of jackrabbits to prairie dogs is 3 to 2. Example number 3. It says, what is the ratio of prairie dogs to jackrabbits? Now, we've already done the work here. So, we don't need to start with these big numbers. We can. The ratio of prairie dogs, 20 to 30 jackrabbits. The ratio is 20 to 30. We already know that this simplifies to 3 to 2. But of course, we'll have to flip-flop it because now we're going with prairie dogs first and jackrabbits second. So if we divided by 10 over 10, we would find that the ratio of prairie dogs to jackrabbits is again 2 to 3. Which of course is a little bit different because we flip-flopped. We flip-flopped the prairie dogs and the jackrabbits. Example 4. Example 4, let's do practice problem C. It says there were 8 Red Sox and there were 10 Blue Sox. Hopefully you can see that. I'm not entirely sure if you can, but that's a red 8, that's a blue 10. And it says, what was the ratio of Red Sox to Blue Sox? Okay, the ratio of Red Sox, 8, to Blue Sox, 10. The ratio of Red Sox to Blue Sox was 8 to 10. We, of course, have to reduce this fraction. Both of them are even, so I'm going to start with dividing both fractions by 2. 8 divided by 2 is 4. 10 divided by 2 is 5. The ratio of Red Sox to Blue Sox is 4 to 5. And we have simplified that fraction. We'll talk about a few of the other practice problems tomorrow. I guess I hope you have a good night, and that's all I have for you today.